Good morning. Today we're going to start in on building the unit circle. This is our trigonometry unit. And the thing we're going to focus on today is the difference between degrees and radians. So first off, we need to know what a radian is. As many of you could imagine, it is directly related to the radius. So the radius of a circle is from the center of the circle to any point on the outside. So all of these, and these other lines will have some significance later. All of these lines, those are all the radius because they go from the center of the circle to the outside. What a radian is the arc length around a circle that is the same length as the radius. So oftentimes when you were in geometry or perhaps other classes that had trigonometry in it, you had the mode on your calculator that was degrees and radians. And we always, or most teachers always had you put it into degrees. And so now we're going to be dealing with radians and what that actually is. So while the degree measure, for example, if this is our measure here, this is the degree measure. Inside, this outside part is the radian measure. So it's that arc length that is attached to that degree measure. So today we're going to learn how to go back and forth between the two. One of the things we need to know for that is if, and I have a piece of information missing here, if this is the point 1, 0, this is what's called the unit circle, and we'll talk more about that in 8-2. But this circle lives on a regular graph, and this is the coordinate 1, 0, which means we have a radius of 1 for our unit circle. So if we have a radius of 1, then we need to find, what we want to find is the circumference, because we want to find the radian measure around the outside. So we're looking at, circumference. Back from geometry, equaling 2 times pi times the radius. Something that you're going to need to get comfortable with is pi staying pi. We're not going to approximate it as 3.14. We're always going to leave it in terms of pi. So this is going to be a circumference of 2 times pi times a radius of 1, which is simply 2 pi. And that is our radian measure for the full circle, 2 pi. Let's also make sure that we have all of our degrees, that we know all the degrees around this circle. I'm going to start with the 90-degree family. So we start over here with 0 degrees, 90 degrees, 180 degrees, 270, and then back to 360 for our full circle. Next thing, let's split that in half and go with the 45-degree family. 135. 180 plus 45 is 225. Make sure you always put that little degree symbol. 270 plus 45 is 315 degrees. And then we're going to do the 30/60 family. So 30 degrees, 60 degrees, 90, then 120, 150, 180 is already there, 210, 240, 270, 300, and 330. So those are all of our degree measures. Now, in class, what students went through was this process of if the circle has 1 unit, what is the exact circumference? We just talked about that. So we have 2 pi r for our distance, or for our circumference. If the radius is 1, that we know this is, then that exact circumference is 2 pi. Now, if we traveled halfway around that circle, starting over here, we're going to travel around here, halfway around that circle. So if we go halfway around that circle, if the full circle is 2 pi, then half of that circle is 1, wrong function, is 1 pi. if we only travel a quarter of the way around the circle, wrong function again, starting over here and going up to there, that's a quarter of the circle. And if we just look at our 1 pi, that's half pi. One thing to understand is if this is half pi, that's the same thing as pi over 2. So most of the time I will refer to it as pi over 2, but it's the same as 1/2 pi. So if you're more comfortable with 1/2 pi, then by all means write it like that. I'm going to get rid of my highlighting here. Whoops. All right. So far we've got half pi, pi. If we travel 1/8 of the way around the circle, that distance right there, if we have that 1/2 pi, this is going to be pi over 4. And if we travel 3/4 of the way around the circle, go start here, whoops, and there's our 3/4. If we think about it this way, we've got 1/2 pi, 2/2 pi, or 1 whole, and then 3/2. So we have 3 pi over 2, 3/2 pi. All right, so that was the intro into it, and there was a little bit more work to converting between the degrees and the radians. I'm just going to go straight into it. So one of the ways to look at it that can be really helpful, so let's look at the degrees first. We've got 0 degrees over here, 180 degrees over here, 90 degrees, cut that in half for 45, 135, and then 30, 60, 90, 120, and 150. All right, so the reason I cut this in half is because we know that half of that circle is pi, and sometimes it's easier to deal with our fractions if we're just dealing with pi. So we know that this is 1/2 pi, or pi over 2, up at 90 degrees. Because that's our distance starting here to here of that whole 2 pi, it's our distance in radians, then or that arc length is the radian measure, that's our radian measure, is pi over 2. So 90 degrees is equivalent to a radian measure of pi over 2. So if I cut the 90 degrees in half, I have pi over 4. And then if I look at this in terms of the families I have, I've got 1 pi over 4, 2 pi over 4, and then that one right there is my other 45, and that's 3 pi over 4. If I look at my 60 degrees, if I cut this, then I am cutting that half circle into 3 equal parts. So that is a 1/3 pi, so whoops, pi over 3, and then 2 pi over 3. So 2/3 of that pi, which is my half circle. And then if I cut that again along the 30, wrong color, along the 30 here, now I'm in 6 equal parts. Well, may as well look at that 90 there. Okay, so if I have this split into 6 equal parts, I have 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. So my measure's over here, pi over 6, and if I go around again, 1/6, 2/6, 3/6, 4/6, 5/6. So 5 pi over 6 over here. And that will continue around that circle. So I'm going to get those parts filled in that I already know. Actually, I'm not. I'm going to go ahead and talk about the families real quick. So the first one we dealt with was that 90 degree family. And that split our 2 pi into 4 equal parts. So 1/4 of that is pi over 2. So that's my pi over 2. So then I have 2 pi over 2 around the side, which is just pi, 3 pi over 2 down here. This is 0, full circle is 2 pi. Okay, so I got all my degree measures in there, so I can also talk about the fractions of the circle, because that really is what this comes down to. So that was my 90-degree family. I already have that. So my 45-degree family is going to encompass that 90-degree family. So I'm going to use the same color on it. So when I break this into sections of 45 degrees, I'm breaking my full circle into 8 equal parts. So if I have 1/8, again with the wrong function, sorry, 1/8 of 2 pi, that's going to give me 2 pi over 8, which reduces to 1 pi over 4, or just pi over 4. So what I also want you to note is that 45 degrees, if I take 45 degrees and I put it over 360, if I reduce that fraction, that's going to reduce down to 1/8. So thinking about that fraction of the full circle. Okay, so now I've got 1/4 pi, or pi over 4, 2/4 pi, 3/4, 3 pi over 4, 4 pi over 4, which is already reduced, 5 pi over 4, 6 pi over 4, and 7 pi over 4. Now, this is eventually going to, the radian measures are going to go on the inside because we have other stuff we're going to need to put on the outside, but just for now, we'll keep them there. All right, so then our 30 degrees, if we break up that little, or sorry, let's do 60 first. 60-degree family. And 60 degrees also encompasses the 180 here. Oh my goodness gracious. So 60 out of 360 is equal to 1/6. 1/6 of 2 pi is 2 pi over 6, which is pi over 3. So 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, and then back around here to 6 pi over 3, which reduces to 2 pi. And then finally, I have my 30-degree family. The 30-degree family, I'm not going to scribble all over this thing, but 30 degrees encompasses both 90 and 60. So again, if we look at 30, get it right one of these days, 30 out of 360, that's going to give me, those 10s can divide out, so 3 out of 36, which is 1/12. So 1/12, whoops, of 2 pi is 2 pi over 12, which is pi over 6. So we have 1 pi over 6. Now, here's the important thing with counting this. You have to go every 30 degrees. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, just most of those are reduced, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi over 6. Whoops. So those are all of our radian measures and all of our degree measures. We're going to add more to our unit circle eventually. But what I want you to note in all these cases, when I was looking at the degrees, I got the fraction of that full circle, and then I multiplied it by 2 pi, or for our full circle in radians. This brings us to our actual conversion. This is simple enough if we're dealing with the unit circle. We can just look at our unit circle, but we also have a lot of degrees that are not on that unit circle. So if I have degrees and I want radians, I'm going to take my degrees over 360. That gives me my fraction of the circle. And then I'm going to multiply it by 2 pi. That's my full circle in radians. And that will give me my radian measure, usually leaving in terms of pi. This can be reduced because if we look at this, this is degrees times 2 pi over 360. 2 and 360 can be reduced because they're both divisible by 2. So that can be degrees times pi over 180. So that can be my reduced version, if you prefer it. Different people remember these things different ways, so it's really important to figure out what works for you. Generally, that happens by being in class and working through some of this stuff on your own. So in the opposite direction, it's still the same theory, the fraction of the circle, so it's going to be radians divided by 2 pi, because that would be our full circle, times 360. And that's our fraction of the circle that I just wrote. That's the fraction of the circle. That's our full circle. So again, that's going to give me my degree measure. One thing that's important, anytime you have those degrees, that you have the degree symbol. The default is not in degrees, so it's important to remember that. The default is in radians. So if I want to reduce this is radians times 360 over 2 pi. That reduces to radians times 180 over pi. That will give you your degrees. So that is the reduced version as well. So those are the conversions you can do, and oftentimes you can look at your unit circle, but it is important to know how to do them without looking at your unit circle. I think that's all I needed to cover in this unit, or in this section. Have a lovely day.